Okay, we're on lesson 35, part 2, question number 18. We're looking at the uh, graphing form of sine and cosine with all of the parameter changes involved. So we would have y equal a sine open k theta minus c plus h, or y equal a cosine open k theta minus c closed plus h. Remember, in the basic form of it, we're learning that everything that we do has to do with the fact that the a is being multiplied, the a is being multiplied and it's outside the parenthesis, and the h is being added and it's outside the parenthesis, and that's going to affect the y moves in the order of operations, multiply first, add second. The stuff inside the parenthesis, the k and the c, we have multiplication and subtraction. They're going to happen to the x moves in the reverse order of operations using inverse properties, and so you would add and then divide. So as we look at the rules that are fixing to pop out, we will realize that those rules were created because of the transformation of parent function rules that we learned in other applications. Okay, so number 18 says, state the vertical shift and the equation of the midline for each, and then graph. Now, since it says graph, we're just going to find everything because that's going to help us. So we're just going to start from the top. Generally, the first thing that we mess with is amplitude. And so let's just go ahead and talk about everything. What will the amplitude of this be and why? The amplitude is your A, and the A of this quadratic is an understood 1, so our amplitude is 1. Now, what that tells us graphically is that it's going to go to positive 1 and negative 1. It hasn't gone to 2, negative 2, or 3, negative 3, or something else like that. So our amplitude is that understood 1. The next thing that we generally deal with is period. And our period is what? What's the formula for period? 2 pi over k. And so we would say 2 pi over k is equal to, 2 pi over k is equal to our period. And what is our k? It's 1 understood over that 2. It's the coefficient of theta. So we're thinking about the k position. And so k is 1/2. Now, to divide by 1/2, you multiply by the reciprocal, and so we would get 4 pi. So we're going to think about our amplitude, and that tells us whether to make the y's go up 1, down 1, or up 2, down 2, or up 3, down 3. And then we think about the period, and that says that we're going to end up way over here at 4 pi. But then what do we always do to the period? We divide our period by 4 to find the gap. So we kind of go over here to the side and say, okay, what's the gap going to be? Well, the gap is going to be the whole period divided by 4, so we're going to have gaps of pi. And we usually just count them off. 1 of those, 2 of those, 3 of those, 4 of those. Even if it was 5 pi over 11, we'd say 1 of those 5 pi's over 11, 2 of those 5 pi's over 11, which would be 10 pi over 11, 15 pi over 11, 20 pi over 11, 25 pi over 11. So you're going to count them off. And so we're going to have pi, and then 2 pi, and then 3 pi, and then we would end up finishing the cycle in a period of 4 pi. So generally, the first thing we want to do, no matter what, is find the amplitude if we're going to graph, and then we're going to find the period. And so we've got our x-axis gridded out and our y-axis gridded out. And then we want to talk about the horizontal shift and the vertical shift. Now, let's talk about phase shift first. Phase shift. Now, how do we find phase shift? The formula is C over K. Now, why is it C over K? Because it's going to be the reverse order of operations. We're going to undo subtraction by addition, so we would add C, and then we would undo multiplication by division. We would divide K. I'm going to show you that again. To find the phase shift, we're going to look at what's inside the parenthesis, because that affects the X, and your X is left and right. It affects the X in the inverse order of operations using inverse properties. Sally, dear, my excuse, please. So we would undo subtraction by addition. So to get rid of a minus C, we would add C. And we would undo multiplication by division. So to get rid of a multiplied by K, we would divide by K. And so we end up with C over K, the C understood to be positive. Okay, so what is the C? The C in this particular equation, if we inserted a parenthesis right here, would be an understood 0 right there, right? So my C is 0, and my K is that 1/2 we used a while ago, and 0 divided by anything is 0, so there was no phase shift. It didn't shift left, and it didn't shift right. Okay? Any questions on that? Did I lose somebody? Let me write this bigger. We've got y is equal to understood 1 sine. Now, it was theta over 2. But in the general form, in the graphing form here, we need a parenthesis. So what we've got is an understood theta over 2 minus c. There's nothing there, so it must be 0 understood. So your c is an understood 0. So you're going to take that understood c of 0 divided by the k of 1/2, and 0 divided by 1/2 is 0. So our phase shift is 0. You understand that? Okay, very good. Thank you. Okay, so we found the amplitude that let us grid out our y's. We found our period that let us grid out our x's. The phase shift is 0, so we don't need to move our x's more x's to the right or more x's to the left, because it didn't shift left or right. Then we want the vertical shift. The vertical shift is what? It's the h. It's going to be that 1/2. Now, what does that tell you? The whole thing shifts up 1/2. So we're going to put a little 1/2 notch in there. Negative 1/2. And then we need 1 and 1/2, right? So there's going to be a vertical shift. So we grid our y's a little more, because everything's going to shift up 1/2. Now, the midline was the x-axis, which was y equals 0. But if it shifts up 1/2, what's going to happen? My midline is going to shift up. So the equation of my midline is y equal the h, as you can see. So the equation of my midline is y equal to 1/2. If it shifts up 1/2, then your midline shifts up 1/2, you see. Okay, now we're still going to have the same standard values for sine, 0, 1, negative 1, etc., except it's going to shift up, okay? So we're going to say up 1 from the midline, down 1 from the midline, and that'll take care of it. Okay, so let's go with those. What was the sine of 0? See, we're acting like we're dealing with right here instead of right here, right, because it shifted up. What's the sine of 0? 0. See that half, that midline, that's acting like my 0 now, you see? Now, what's the sine of pi? Okay, what would be the next number on sine? 0. What was the sine of 90? 1. So my next number would have been 1. Well, it's still going to be 1 with all these transformations, but it's actually 1 up from the midline, right? Which is at 1.5 actually. up 1 from the middle. See, because sine goes 0, up 1, 0, down 1, and back to 0. But this isn't really pi because we changed the period. Let's go back. Let me draw this. If we look at the standard graph of sine theta and sine theta, in the typical graph we would have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. 3 pi over 2, negative 1. And then we're back to 0. We're going to get those same numbers, you see. So even all the transformations, we just redrew our graph, but we've got it set it up in 4 jumps, 4 blocks, shifted and all. So we're still going to deal with 0, 1, 0, negative 1, 0. We're just going to do it from the midline. So from the midline, we're on it, 1 above it, back on it, 1 below it, back on it. That makes sense? But we're going to do that in the period of 4 pi. And so we're on it. The next jump in the standard graph would be up 1 from it. The next jump would be back on it. The next jump would be 1 below it, and 1 below the midline would put me at negative 1/2, and then back on it, and then I've got my graph, okay? So once we block off our period and we do all of our shifting and change all of our numbers, we still graph using 0, 1, 0, negative 1, 0. And it's all going to end up where it's supposed to end up. Okay? So we basically adjusted our whole grid so it would fit our pretty numbers. Instead of keeping our grid the same, if we had kept all of this where it was at, and we'd have left this pi over 2 and this 2 pi, then you'd have had to do some crazy figuring out to figure out where it went. Because we'd be saying, okay, we're going to plug pi over 2 into this. So we're going to have pi over 2 over 2. We have sine of pi over 2 over 2 plus 0 plus 1/2. So sine pi over 2 over 2 is sine pi over 4. And sine pi over 4 is square root 2 over 2. And square root 2 over 2 plus 0 is square root 2 over 2 plus 1/2. And so now I've got square root 2 over 2 plus 1/2. And I'm going to try to figure out where it's at. You see what I'm saying? We avoided all that. It's a whole lot easier to stick with your zeros, ones, negative ones, and zeros. So anyway, that's doing what we're doing. Any questions on 18? Okay. See, at pi over 2, according to this, you see what I'm trying to say? Pi over 2 would be up here in no man's land somewhere. It would actually be at square root 2 over 2 plus 1/2, which is just hanging out there somewhere. You're not really going to get your peaks and valleys of your curve if you just plug in your normal numbers, okay? All right. Any questions there? So that was 18. Number 19 gives us a graph of, it gives us an equation of a cosine, and we want to make the graph, correct? So state the amplitude, state the period, state the phase shift, state the vertical shift, and then graph. Okay, so that's a cosine one. I've kind of made a mess out of my sine stuff here, so we'll just leave the cosine stuff and go from there. All right, so number 19, my equation that I was given to begin with was y equal 3 cosine. Thank you. All right. Now, if we're going to graph, we really need to go through all those same things again. And what's the first thing we always deal with? Amplitude. And so we know the amplitude is the A, which is 3. So the amplitude is 3, so if I start graphing over here, my ditto marks didn't come out very even there, but we kind of got the idea. So that's what that tells us, right? The amplitude is now 3. All right. Then the next thing we generally deal with is the period. And the formula for period is 2 pi over k. So we're going to have 2 pi divided by our k, which is 1 understood. Get 2 pi divided by 1 is 2 pi. So my period is 2 pi. Now when we figure out our period, what do we always do? We make a gap so that we can stay on those pretty numbers, 0, 1, 0, negative 1. So we're going to take 2 pi divided by 4 to get our gap. And so our gap is going to be pi over 2. So we want to make it all the way to 2 pi in jumps of pi over 2. So we're going to have pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, some of which reduced, right? Okay? Let's see what we've done so far. So we've got our amplitude that helped us begin to grid our y's. We may have to make some adjustments if there's a vertical shift. We found our period, which helped us begin to grid out our x's, but we again may have to make some shifts. If there's some horizontal shift, we may have to make some changes. And so then we want to find the what next? Phase shift, which is your left and right shift or your horizontal shift. And the formula for phase shift is C over K. The C is pi over 2, and it's positive because we're going to get rid of subtraction of pi over 2, and we're going to get rid of multiplication. So we're going to undo subtraction by addition, so we would add pi over 2, and then we would undo multiplication by division, so we divide by the k of 1. Add c, divide k. We're undoing inside the parenthesis. And so we're going to have pi over 2. Well, what does that mean? It means the whole thing shifts to the right pi over 2. Okay? It means the whole thing shifts to the right pi over 2. So what would have been here is going to end up here. What would have been here is going to end up here. What would have been here is going to end up here. What would have been here is going to end up here. Which means I need 5 pi over 2 out there. Because it's going to shift to the right pi over 2. So I need another ditto mark out yonder. Pretty good so far. Okay? What do we find after phase shift? Vertical shift. What's the vertical shift? The H. And what is the H? I'm going to have to do it in here. It's an understood plus 0. There was nothing out there, so it must have been a 0. So my vertical shift is my 0, and the equation of my midline is y equal h, or y equals 0. So my midline stayed the x-axis. There wasn't a vertical shift, so I do not need to regrid my y's. Okay? Now, we're dealing with cosine. What are my cosine numbers? 1, 0, negative 1, 0, 1. Right? Cosine 0 is 0. Cosine 90 is 1. Cosine 180 or pi is negative 1. Those are the numbers we're going to deal with. Now, here's what we're thinking. We've got this phase shift we got to deal with, okay? So what would my first number have been? It would have been a 1, but now it's a 3, and so on, okay? Now, where would the 3 have been? 0 would have been marked with 3, but there's a horizontal shift of a half. So the thing, since 0 would have been with 3, we got to shift to the right pi over 2, so pi over 2 is with 3 now. Now, we really don't have to think that but once. Now every pi we do our next number, right? So the 3 over 2 started pi over 2 to the right of where it would have started. So now we go to the next number, 0. And we go to the next number, negative 3. And we go to the next number, 0. And we go to the next number, positive 3, way over there at 5 pi over 2. So we basically shifted the first one, and then we just followed the leader. And so we have a cosine wave with all of those parameter changes. Pretty slick. I like this. It's like a big jigsaw puzzle. It's kind of neat. Yes, sir. What's that? Graph where x equals 0. I'm going to pause in just a second. It took me a second to understand the question. The question was, should we go back and do this part of the graph over here and figure out what it would have been at 0? Well, what would have been before that? What would have been in the sequence before the 3? Back to 0, right? Because we'd just be repeating this sequence, and then there would have been a negative 3. So go back to the 0, it would have been 0. So yeah, that would have been the next little piece. We really don't have to go back to 0, because what we really did is we took that whole thing, what we would have had, and we shifted it to the right pi over 2. And so I'm fine if you just graph one full period. See, what's in green is one full cycle. And usually all we graph is one full cycle. If you add a little to the left or you add a little to the right, that's going to be fine. If you want to go back to the axis, that's fine. But all I'm going to require you to do is graph one full cycle with all of those parameter changes involved. Any questions on 19? Okay. Number 20. So there's our form that we're graphing from. Number 20 gives us the amplitude. It says that the amplitude is 50. It gives us the period. It says that the period is 3 pi over 4. Have a good weekend. The phase shift, thank you, is pi over 2. The vertical shift is negative 25. So this time we're getting all of the numbers, and we're going to go back and find the letters. A while ago we took all the letters from the equation and came up with the actual shifts. Okay? So we're going to still be using our formulas, but we're going to be undoing in those formulas rather than doing in those formulas. Okay, so what's the amplitude formula? Amplitude equal absolute value A. So amplitude equal absolute value A. So 50, that's your amplitude answer, right? Equal absolute value A. So amplitude equal 50, amplitude formula, amplitude equal absolute value A. We put 50 in place of amplitude, we get 50 equal absolute value A. So the question is, absolute value of what is 50? And the answer is plus or minus 50. So little a, we will replace in a minute with plus or minus 50. We're finding our plugins by undoing, okay? Okay, now the next thing we have is period. What is our period formula? Our period formula is 2 pi over k. And what's our period answer? 3 pi over 4. Our period answer is 3 pi over 4. Our period formula is 2 pi over k. So we'd put our formula equal to our value, 3 pi over 4. Now this is a proportion. Somebody say we set that up? We're looking for the k that would create that period. We're going to cross multiply. 4 times 2 pi is 8 pi. Equal to k times 3 pi is 3 pi k. We're looking for the k to plug in. We're going to get rid of multiplication by division, so we're going to divide by 3 pi. The pi's cancel, and we get k is equal to 3 over 8. That's going to be our plug-in for that position k. Over 3. Thank you. Those little looks y'all make help me. 8 over 3. All right. Thank you. That was weird. Okay. So we've got our A and we got our K. We need the C and we need the H. We're working our way right down the line in the same order we did a while ago. Okay. So phase shift. Phase shift was... Here's my phase shift answer. My phase shift formula is C over K. So phase shift formula, C over K, equal phase shift answer, pi over 2. Now that would be a problem if we hadn't done things in the correct order, but we did. We just found out what K is. See, we would have had a problem if we hadn't already found K, because we'd have had too many variables. So we're okay because we've already found K. And so we have C over K, which we found out was 8/3, is equal to pi over 2. It's probably going to be easiest to cross multiply. That's what I think I'll do here. Cross multiply. And so we're going to get 2 times C is equal to 8/3 times pi. I'm just going to do it like this to get rid of that 2 understood to be over 1. We're going to multiply by the reciprocal 1/2. Is that good for everybody? If we divided by 2, we'd have to multiply by the reciprocal anyway because there's a fraction over there. And so we're going to get C is equal to 8 pi. Whoops, we should reduce. I'll just cross reduce as I go. 2 goes into 2 once. 2 goes into 8 4. 4 pi over 3. So there's my plug-in for C. And my vertical shift is 25. And what's the formula for that? There's not really one. That's just plain old H. So there's my H, right? That is my vertical shift. Good thing because I was out of room. All right, so there's our vertical shift. So we found, I'm going to use a highlighter so we can actually find everything we found. We found amplitude. That's going to get plugged in there. We found K. That's going to get plugged in there. We found C. That's going to get plugged in there. And we found H. And that's going to get plugged in there. And we're going to have our equation, right? So our equation is going to be, I'm just going to take a little chunk out of here. So our equation is going to be y equal a, which was plus or minus 50 sine, k, which is 8 over 3, so we'd say 8 theta over 3, minus my c, which is 4 pi over 3, close, and then my h, which is a minus 25. So we wrote an equation in a sine equation that involves those particular transformations. Any questions on number 20? Okay. Wow. Everybody good with that? Number 21. I'm going to go ahead and do this, and if we run out of time, then I'll just keep talking, and y'all can just start walking. How's that? No, I'm just kidding. Or you can stay till it's over. All right. So, number 21. Number 21, we're going cosine, so we want y equal a times, I keep wanting to do that, a cosine k theta minus c plus h. Okay, so they gave us the amplitude of 3.5. They gave us a period of pi over 2. They gave us a phase shift of pi over 4. And they gave us a vertical shift of 7. Okay, so we'll start with amplitude. What's the amplitude formula? Amplitude equal absolute value A. So amplitude number 5, 3.5, is equal to absolute value A. So we would ask the question, what has an absolute value that turns into 3.5 plus or minus 3.5? Absolute value what is 3.5? Positive or negative 3.5. I said it better than the period. The formula for period says that period is equal to 2 pi over k, and the period came out to be pi over 2, and that's a k on the bottom, 2 pi over k. So the period is 2 pi over k, and the period answer is pi over 2, and so to solve, we're going to cross multiply. We'll get 4 pi is equal to k pi. We want the junk off of k, so we divide by pi, and we get k is equal to 4. So we needed this. There's our amplitude. There's our A, We needed this. That's our K. Phase shift is going to help us find our C. Phase shift. What's our phase shift formula? Phase shift formula, PS, is equal to C over K. And the phase shift answer is pi over 4. We have two variables, but we've already found the value of K, which we can plug in. So we're going to have C over 4 is equal to pi over 4. It's pretty obvious C is pi, correct? So we're going to cross multiply as if we didn't know that. 4C equal 4 pi. Get the junk off of C, and so we get C equal pi. So we've got our A, our K, our C. We just need our H, and we know that H is the phase shift. the vertical shift. H is the vertical shift, and so H is 7. So if we plug that into our formula, we're going to have y is equal to my A value, which was plus or minus 3.5, thank you. Cosine, open, it's time for K. The K value was 4. Theta minus my C value was pi. Time for my H value, 7 plus 7. Any questions on lesson 33 to 35? You will do this test without a calculator. As you can tell from the video, we don't need a calculator. We did all of that out of our head, so there's not a need for one. You just have to know your unit circles, especially your quadrantal angles, and understand how to subdivide our period into 4 pieces and get our stuff in the right location. Any questions on that?